All right, so thank you for joining me for this presentation. My name is David Anderson, and I'm an independent software developer and the owner of Decom Productions. And today I'm going to be talking to you about the event-based asynchronous pattern. And what this is just a simple set of patterns and practices used to implement asynchronous behavior into components and objects in your code. So let's actually talk a little bit about what exactly I'm going to cover today. And we're going to be implementing an HTML client component, and this will be an aggregate component, so you'll be able to instantiate it and use it without any configuration. So you won't have to set any properties or create any other objects, anything like that. So we're going to start off, I'll talk a little bit about the design of the component. Then we'll implement the default synchronous implementation. And the goal behind this is we're just going to create a simple HTML client object that has a method called download HTML, and it will return a string as a result. And basically, this is just a wrapper around an HTTP web request. Once we get that done and we test it and it works, we'll add the asynchronous pattern on top of that. And the cool thing about this is the synchronous pattern, like I said, we'll use return values. The asynchronous API will expose the event model. So we'll have a download HTML async method, and it'll return the result through an event. Both of these will use a single private implementation. So there will be a single method that actually does all the work. So we're not duplicating any code. Now, the event-based asynchronous pattern is implemented using three main objects. We have the async operation, which is just an object that tracks the lifetime of an async operation. We have the async operation manager, which we use to create the async operation. And it also provides concurrency management for classes that support asynchronous calls. Next, we'll have delegates and callbacks. We'll have just a normal delegate, and then we'll have a send or post callback, which lives in, all this, by the way, lives in system.component model. And then we'll have the send or post callback, which just represents a method to be called when a message needs to be dispatched to a synchronization context. So three very basic things we'll be working with. And why is this pattern relevant today in today's standards? So with C# 5.0 and dotnet 4.5 with the task parallel library, which was actually introduced originally in dotnet 4.0, why is this relevant? Well, not everyone can utilize C# 5.0. Not everyone can utilize dotnet 4.0 and 4.5. So you may be stuck in a pre-C# 5 world and pre-dotnet 4 world where you can't use those tools, so you kind of have to use other things. This pattern specifically is very easy to implement, very easy to wrap your head around, doesn't require a whole lot of work, it's thread safe, and it's a proven practice, and it's used throughout the .NET framework in many places. The downside is it can create a little bit of spaghetti code if you're not used to it. .NET 2.0 and later, even if you can use components of later frameworks, let's say you have an assembly that uses .NET 4.5, but you have another assembly that's .NET 2.0. That .NET 2.0 assembly can't take advantage of the task parallel library. So you're still stuck in the same situation where you need to use something else. So this is still very relevant in today's standards and practices. So let's go ahead and jump straight to code, and we'll be doing this in Visual Studio 11 beta. And I have just a normal WinForms app. I haven't done anything to the app yet. Project name is Decom Productions for our root namespace, and then I have two folders that I have added, Forms and Web. So our component will live in the Web folder, and then our shell form will live in the Forms folder. And we'll add that real quick. So we'll add a form, we'll call this shell form. And since we're on Windows 7, we'll go ahead and set the font to Seago UI 9 point, and we'll set the backdrop to window and the foredrop to window text. And this will be a fixed dialog, no minimize or maximize. So if we run this, we just have our normal run-of-the-mill Windows application. We'll set our form by importing our namespace and run it. So we just have a WinForms app. Okay. So let's move on and actually create our component. First, let's talk a little bit about the design. So let's comment out this code real quick. No, we'll leave that there actually. So let's say I want this object to work just like a web client. We have the system.net.webClient class. Well, I know that I want to be able to create the object, so we'll say HTML client equals new HTML client. And let's say I want to download the HTML synchronously, so I want to say string HTML equals client dot download HTML. And let's say I want to pass in a string as a parameter. Okay. So that kind of defines how our synchronous surface is going to look in the API layer. Now, if we have an asynchronous version, let's say we want to say something like download HTML completed, and let's say we want to hook up an event using a Lambda, and let's say we want to download HTML async, and let's say we still want to pass in the same parameter. And then let's say we want to consume our event and access the HTML through something like event arguments dot HTML. So we kind of have the overall design on how this component should look already. So we can actually go ahead and start implementing that. Let's comment out the asynchronous stuff for now. And let's actually add our class. So we'll add a HTML client class to our web folder. This will be a public class, and we'll document this real quick. Okay. And because we want to design this as a component to be able to work with the WinForms designer, we're going to inherit from system.component-model.component, which will give us the basic designer functionality. And then we're going to add a description tag to our class. Okay. And we're going to add an explicit default constructor. We're not going to use it until we start implementing the async stuff. Okay. And we know that we have some default methods in our design. We had a public string download HTML, which took a string as a parameter. But let's create another one on top of that, which takes a URI as a parameter. And let's take our string overload and simply return the result of download HTML, and we'll create a URI. So we're just going to call our other overload. And then for this one, we'll just say return internal download HTML and pass in our address. Now the internal download HTML, this will be our method that'll be shared amongst all the implementations. This will be the method that actually does all the work. So we're going to separate this into two layers. We're going to call this public API. And we'll document this and we'll say downloads and returns HTML from a request. We'll do the same thing on our other public method. Okay. And let's actually implement our work. So we'll say HTTP web request. And we'll pass in our address. And because we're using a URI, it works well with the web request methods. And we need to do a web response. And we'll do string HTML equals empty, and then we'll create a stream reader. Get response stream, and this should be a equals. And then we'll say our HTML is equal, and then we'll just read all the way to the end of the stream. And then we'll return our HTML. Okay. So now that we have our internal implementation done, we can actually test that. So we can go to our program file and we can import our .web namespace. And we can set a breakpoint at the end of our application entry point. We could actually run and test this. So we can see that our breakpoint was hit. And if we investigate the contents of HTML, we can see that we have the result of our web request. So our synchronous implementation, our component is actually done. This is ready to use for WinForms, drag and drop from the toolbox, all that good stuff. The bad part is it's synchronous, so anywhere you use this on your form, it's going to block. So what we're going to do now is we're going to implement the asynchronous implementation. And we'll call this implementation. Now we're going to we're done with our synchronous stuff, so we can comment that out of the way. And we can do another region, and we'll actually, excuse me, that's our public API. So we're going to create another method, and this will be public void download HTML async. And again, this will take a string as a parameter, and then we'll have another one that takes a URI as a parameter. And just like our synchronous methods, this will just pass through the URI version of the method. Now in this method, we actually have to do the work. What we're going to do is we're actually going to take and create our async operation through the async operation manager. And because we don't care about user states for this example, we're just going to pass in null. And now what we need to do, we need a callback to actually execute this asynchronously. Because remember that the async operation is just to track async operations in memory. It doesn't actually execute any code, and it doesn't actually specify what thread that code should go on. So we need a callback that takes a method that actually does the work, because we're going to do callback.begin invoke, which will take our address as a parameter. It'll take our async operation as a parameter, and it'll take those two null arguments. And this is just going to be a delegate. So we're going to declare another region up here called callbacks, and then we'll have private delegate void internal. Well, actually, it would be download HTML callback. And it'll take a URI as a parameter, and it'll take an async operation as a parameter. So now we can see down here that we have our callback. We can hit .begin invoke to execute it on an arbitrary thread. It takes our address and our async operation as parameters, and then the last two parameters we really don't care about. So they're not important at this point. All right, now we need to, just like our synchronous download HTML method, which is internal, we need an async version, and this will be internal download HTML async, and this will take our address as a parameter. It'll take our async operation as a parameter. And then we can simply cut, because we're now running on an arbitrary thread, we can simply do string HTML equals and then call the synchronous version of the method that actually does the work, pass in our URI, and we're done. Now, because we're on the next line of code and that ran synchronous, we're ready to return to the caller, meaning that we're ready to return the result. So what we need now is a way to actually report the HTML to our event. So we need some event arguments. We're going to go to our web namespace and add another class, and we'll call this download HTML completed event args. Now, anytime you're dealing with asynchronous events and you're going to return an asynchronous result through an event, you should always inherit from system.componentModel.async completed event arguments. And we're going to create our constructor, which will take our HTML as a parameter. But we also need to specify the base class parameters, which is an exception, a canceled Boolean, and a user state, which we're just going to specify as null because we don't care about that. And we're going to preserve the parameter order, but we're going to omit the user state because, again, we're just passing in null. And then we're going to do HTML equals HTML, and then we'll specify an immutable property. Okay. So now we have our event arguments class that we're done with. Now we need to actually create our event. And just using the default event handler by specifying our event arguments as the generic. And this will be download HTML completed. And then we need to create our protected virtual method. And then this will take our event arguments as the parameter. And then what we'll do is we'll create a copy of our handler. And then we'll check to see if it's null. If it's not, we'll simply invoke it. And there we go. Let's document our event. And then because we're going to use this in the designer, we're going to add our description tag. And we're done. So we're done with the events portion of this. And now what we need to do is we can actually create our event arguments in our asynchronous methods. We can say equals new, and we can specify the HTML. And we have a IntelliSense issue going here, but we know the first parameter is an exception. We know the second one is a Boolean for canceled, which we don't care about. And then we know the third one is actually the HTML. Okay. Oh, that's why. Download data, download HTML, completed event arguments. Okay. Now we need a way to actually report that this is done. So we can actually take our async operation object, that's a parameter, and we could say async operation.post operation completed. And we need a callback to do this. So before we can finish this line of code, let's create our callback. So this will be private send or post callback, which also lives in system.threading. And this will be download HTML completed callback. And then we're going to go up here to our constructor, which we reserved some space for, and create a method called initialize callbacks. And all we're doing here is simply initializing our callback. And we're going to specify another internal method called internal download HTML completed. Let's comment our constructor real quick. So we're done with our callbacks. And we're initializing our callback, and we need to specify another method called internal download HTML completed. And here, we're passing in our event arguments. So we're going to say state. and then we're simply going to call our event. Let's move that back up to here. There we go. And now we could finish this line of code. We could say pass in our callback, which is download HTML completed callback, and then we're passing in our event arguments. So this is basically going to make sure that we're posting our event arguments to the calling thread, which is our UI thread. And we have a problem with our method call here because I accidentally specified download data event arguments again. So it should be download HTML completed event arguments. Okay. All right. And we should actually be done. Now, normally this returns very quickly. So in our actual method that does the work, we're simply going to do a thread.sleep for 5 seconds to simulate a long-running task. All right, so we should be able to build this. And we should be able to uncomment all this here. And let's just add a blocking call real quick. And if we set a breakpoint in our event, we should be able to run this. It should wait for about 5 seconds. Let's close this first. So we should get about a 5-second delay, and then it should return into our event, returning the HTML. And all of this is being done asynchronously. Whoops. Oh, I forgot to take our string overload as calling itself. So we need to do new URI and then call our URI overload. So now if we run this, we should get about a 5-second delay, and then it should return, hit our breakpoint. Okay, so we can see by inspecting the HTML property that we have the HTML returned, and we're done. So now we're going to hook this up to our form. So we're going to just erase all this code. Okay, we're done with that. Clean that up. And we'll just use the same comment for our other asynchronous API. All right, let's build this one more time and go to our form. Now you can see that in the toolbox, our HTML client is there. We can drag and drop that onto the form. We can inspect the properties in the property window. We can actually even see the event. So we can say download HTML completed. And we're just going to do on download HTML completed. I'll document some of our methods here. Okay. Now we're going to do a couple things. We're going to grab a couple labels, a progress bar, and let's grab 2 buttons. And for our label, we'll say that this is going to be 11 points. And its text color will be 003399, which is blue. We'll just say HTML client example. And then for this label, we'll say demonstrates event-based asynchronous pattern. And we'll take our progress bar and just expand that out. And we'll move our 2 buttons up a little ways. just the modifier for our progress bar. And then for a button, we'll call this button async. And then we'll call this one button sync. And we'll say get HTML async on one. And then we'll just say get HTML on the other. And then we'll set their auto size to true. And then we'll do get HTML async for the click event. And then we'll do get HTML for the other one. Now for the synchronous event, let's go ahead and we'll do string. Well, let's disable the buttons first. So we'll say button sync enabled equals false. Button async enables false. Then what we'll do is we'll take our progress bar. We'll set the value to 0. And then we'll set the style to marquee. And then we'll say string HTML equals our HTML client, download HTML, and then we'll just pass in some web address. And we'll say new URI. We'll use the URI parameter. And then once that's done and it returns, then we'll re-enable everything. So we'll say the buttons are enabled. And then we'll say the progress bar value is its maximum. And the style is blocks. And up here, we could, instead of 0, we could actually do progress bar minimum for the value. So if we were to run this and click get HTML, we can see that the user interface is now blocked. It's locked up. I can't move the window. I can't do much of anything. And then it returns finally, and now we get our UI comes back to life. So we don't want that behavior. What we want to do is get the asynchronous behavior. So there's a couple things we're going to do. In get HTML async, we're going to do almost the same exact thing. We're going to disable the buttons, set up the progress bar, except we're not going to consume a return value. We're going to call the asynchronous method instead. And then only after that is complete and our result is returned, will we go down here to our event and get the result. So we can say down here string HTML equals E HTML in our event arguments, and then we'll re-enable everything. So if we were to run this, you can see again, we have our synchronous behavior. User interface is blocked, locked up, can't do much of anything at all. And then when it returns, we get it comes back to life. And if we get HTML async, we can see that everything is updated properly. I can move the form while the operation is running, and it returned, and the UI came back to life. Well, it was always alive because we're running asynchronous. But so again, we have the synchronous behavior, not much of anything, can't move the form, and then we have the asynchronous behavior, which is very nice, very smooth, user interactive. So we can do other things while the operation is running. And we could set a breakpoint in our event handler down here. And we could run this again. And I could say get HTML async. And we could do our different operations or whatever we need to do while it's running. And then when it's done, it'll return to our event handler, and we can access the HTML that was returned from the web request. All right. So that's all there is to it. Like I said, the event-based asynchronous pattern is not very hard to implement at all. We went through that in about 30 minutes. Once you get your head wrapped around it, you could probably complete it within anywhere from 5 to 15 minutes, depending on how many async operations, how complex is your object. So that whole object is 118 lines of code, not very much at all. So I'll include the source code for download. This project, it's already documented, as you can see, and I'll post this. This will be posted to our blog, which will include the download link, and then we'll include the download link to the video on the YouTube as well. All right, so again, I thank you for joining me for this presentation, and I definitely look forward to more to come in the upcoming year.